Reminder, a trinomial means there are three terms, correct?
Correct.
Ax squared plus bx plus c. When we were doing simple trinomials the last couple of days, you never really had to worry about this a value, right? A simple one might look like x squared plus 13x plus 40. It's a trinomial. I don't have anything happening in that first piece. It's just an x squared. We kind of figured out the last couple of days, or actually over the last couple of weeks, and now we're using the fact that trinomials break into two binomial factors, so 2 by 2. What makes simple ones so awesome and simple is, how do I get an x squared in the front? X and x. So you basically don't really have to think about that first term at all. You just know it's x and x. And then what's the pattern to get the back two terms? What's the pattern that gives you 8 and 5? They add to make the middle, they multiply to make the back, right? So they add positive 8 and positive 5, adds together to make 13, multiplies together to make the 40. It's much, much simpler. Well, when I go to a complicated one, like 6x squared plus 19x plus 10.
Didn't you show this in the video?
I showed in the video, I did. I showed one that had a greatest common factor. So that's a good question. Does this have a greatest common factor?
No.
6 and 19 and 10 don't have one. If there was a greatest common factor, there's a chance, and in the notes I did this, and yesterday if you were in class I did this, where it may not look simple, but you could take a greatest common factor out and it then turns into something simple. This one, there's not a greatest common factor there. So, is that a trinomial still?
Yeah.
So what is it going to break into?
2
Still going to break into two binomials. But what makes this complicated is I can't just say, oh, it's x and x. It makes x squared. So maybe 2 and 3. Red, is that what you were going to say? Alex, same thing?
But 2x, not just... Yeah.
So maybe 2x and 3x will start us out. That's reasonable, right? That would make 6x squared.
Yeah.
Are there any other combinations that might make 6x squared, though? It could be 6x and 1x. But I'm going to stick with 2 and 3. Maybe that's reasonable. And then here's how we're going to basically do this at this point in our lives. We're going to guess and check.
Yeah.
So I'm going off a hunch that maybe 2x and 3x will make 6x squared. So maybe that's what my binomials start with. All right, kids. Start working out those brains.
We're wrong.
Let's guess and check. What can I put on these that will make the 19 and also make the 10?
Wait, you still add.
I think I got it.
You still add for the 19.
So yeah, well, you're gonna have to kind of test them out. Like, you might try two numbers and see if when you multiply it, you get 19 from right here and 10 in the bottom right corner. 3 and 5. Carlos, you want 5 up here?
But they're gonna make 10.
3 is
So hang on. So let's test Carlos's answer.
Never mind.
So he knows, and a lot of y'all know, but just to prove how we know. So he tried 5 and 3, and I'm guessing the reason he tried 5 and 3 is because that would make 10x and 9x, and he got the 19. But what's the issue? This makes a 15, and I don't want a 15 right there. I really want a 10. So it wasn't a terrible guess, Carlos. He got the 19, but unfortunately it doesn't work. We are not going to go decimals. To whoever just said 5.5, we're not going decimals. Okay, Ione, what do you think?
I got 2 and 5
2 and 5. Where do you want the 2? Up top or on the side?
on the side.
So you want 2 down here, and you want 5 up here?
Give us 16.
So let's see. That'll give me 10x. Hang on. It'll give me 10x, it'll give me 6x, and it'll give me positive 10. So Ione made the positive 10, but she didn't have the 19. Switch them? I feel like I'm on an episode of Sesame Street where like it's a back and forth, but I'm essentially ignoring you. Okay,
I know it now.
So you think if we switch the 2 up here and the 5 down here?
Yes, that's what I
Okay, let's see. 2x times 2 gives me 4x and 15x. There's 19. And it gives me the 10.
That's what I got.
Congratulations. You cracked the code after, what, 3 attempts? 4 attempts?
Actually, that's my first.
So,
do this with everyone.
2x plus 5 and 3x plus 2. We just confirmed that that makes what I want it to make. So those are the factors. Now, does that seem like the most efficient way to do this?
Definitely not.
No.
Way too
Okay? When I was in middle school, that's what we had to do. There were no cutesy little tricks. They weren't trying to make our life easy. So it was truly just a process of guess and check, guess and check, guess and check until you figure it out. Now, I'm going to take a shot at y'all. We were much stronger at our multiplication facts, so checking was a lot quicker than it was for y'all. But whatever.
Do they have calculators?
I'm going to show you a more efficient way. Okay? So here's how I'm going to do the same problem, and I'm going to show you kind of a shortcut. 6x squared plus 19x plus 10. I'm going to use the box to work this out, and I'm actually going to do it over on the side because I'm going to write some notes underneath it. So I'm going to draw my little box. I know it's going to be a 2 by 2 box because we've already confirmed trinomials go into 2 binomials. All right. Have y'all kind of picked up on the fact that the first term always goes in the first box?
Yes. You noticed that.
And the last term, that 10, always goes in the last box? We're not going to have remainders on these, okay? We're not going to have that weird remainder thing that popped up when we were dividing. These are all going to work out clean. So really, now what I need to figure out is what are these two mystery numbers? And there's a trick to them. They add to make 19, which is kind of what we were seeing here, right? They had to add together to make 19. But instead of multiplying to make 10, does 15 and 4, 15 times 4 make 10?
No.
No. You know what they multiply to make?
What?
What's 15 times 4?
60.
You know where the 60 comes from?
6x.
Oh my god.
6 times 10.
Whoa.
Okay? So it's still kind of like the warm-ups we've been doing. They're going to add to make the middle, and they're going to multiply, but instead of just multiplying to make the back number, they're going to multiply to make the front times the back.
This again.
So then you go, oh, it's 15 and 4. Add to make 19 and multiply to make 60.
Isn't that what the-
And so 15x. And so I wrote it in the other order. Let's see if it matters. I probably shouldn't have done
You
that.
just switched the 3 and 2.
So this is great, but you're like, that doesn't tell me what the two binomials are. Now what I do is I look and see, okay, what do 6x squared and 4x have in common that I can put up here? 2x. Its greatest common factor. What's the greatest common factor between 15 and 10? 5. What's the greatest common factor between 6 and 15? 3 and an x.
Oh my gosh, I'm shook.
And then what's the greatest common factor between 4 and 10? 2. And if I did it all correctly, then that makes 6x squared, 15, 4, and 10. And it gives me those same answers.
I love it.
2x plus 5, 3x plus 2. All right.
how the 60 comes in.
So here's what I'm going to do. And we're going to do lots of examples that'll make more sense. Right now, let's just write an outline because I know that sometimes y'all like having written steps. So what we're going to do is we're going to use the box. But when you are factoring, you fill in the inside first. That's kind of a key thing. When you're multiplying, you start on the outside of the box and fill in. When you're trying to break it into the factors, you start on the inside and work out. And then here's how you fill up the box. I'm going to draw a box. I know it's a 2 by 2 box because trinomials make 2 by 2 boxes. I'm going to put the first term in the first box. I'm going to write the last term in the last box. So that's how I got the 6x squared and the 10, the first term and the last term. And then these are always going to be some number with an x. Some number with an x. you need on these two numbers that, and it may not make sense right now. It's okay. Just write it down and you can reference back to it. We're looking for two numbers that add to make what?
The middle number.
There you go. Add, to make the middle term. That's exactly the same as the simple ones. They're going to add together to make that middle piece of my trinomial.
And multiply together to get the first and last.
They multiply,
And that's how
To
you do
make.
that thing, right?
and that's how I got the 60, is they multiplied to make 6 times 10. To make the first,
And 15 times 4 is 60.
Yes.
And plus that is 10.
you are exactly right. So they multiply to make the first times the last. And then after you filled in all your box, then we're going to factor out the GCF. We're going to do a lot of examples to practice this, so don't panic if you're really iffy on it. But I'm going to make another video for examples.